Alright, in this video we're using an ice table to try and figure out, what is it? Equilibrium constant. So they give us this equation, and then they say they've got 0.800 moles of POCl3, and it's enclosed in a 0.5 liter vessel. So the concentration is going to be equal to moles, that's this, over the volume 0.5. So when you divide that, I think that comes out to 1.6 molar. So that's the initial concentration of the POCl3. So initial is 1.6 molar. So they put that in a vessel and then they let it do its equilibrium thing. So some of it's going to go over to this other side, but initially the concentration of those guys are 0. And so they're going to increase by a certain number. Each of those will increase, and this one's going to decrease by a certain number. And we might be able to see what that is. We'll have to figure out what x is here in a second. Let's just make sure, I think the ratio is 1 to 1 to 1, if I'm not mistaken. So all those x's are right. I don't have to have a 2x or anything in there. Okay, so this will be my change. And then at equilibrium, it says it's found that the vessel contains 0.259 moles of chlorine. So here at equilibrium, I've got 0.259 moles. But again, it's 0.259 moles, and I need that as a concentration. So I'm going to divide that by 0.5, because that's how big the vessel is. So when I divide that, I think that comes out to 4, what's that? What does that come out to? 0.259 divided 0.5, oh, 0.518. 0.518 moles per liter. So this one is 0.518. So this x must be 0.518. So if this one gained, it would have to gain the same amount, and then this one would have to lose that same amount. So I've got to go 1.6 minus that 0.518. I get 1.082. Okay, hopefully that's making sense. Often we get mixed up with the mole part, or just using moles or using concentration. And when you're doing this ice table, you can do it either way. Have it all moles or all moles per liter, but you can't mix them up. Okay, and then my constant of equilibrium is going to be the concentration of the two products. So that would be they're both 0.518 divided by the concentration of the reactant, this one. So if I do that, 0.518 divided by 1.082. Okay, 0.518 times 0.518 divided 1.082 equals 0.247988, etc. And that's smaller than 1. Since it's less than 1, then the equilibrium is probably favoring the left side just a touch. Hopefully that helps with that question.